Hello. On this skill, we're going to learn how to find the 5 characteristics of a rational function. Our goal, of course, is to graph these, but to graph them, we need to know how to find the 5 key things. And we've done each of these independently. We're going to put it all together into one big step now. And just like before, our first step is to factor the numerator and denominator. And I factored a -3 out of the front because I always like my x squared term to be positive. And by factoring out the -3, that trinomial on top is now positive. I can now easily factor this thing. And the other thing that's not listed on this that sometimes you'll be asked is what's the domain? And we've talked about the domain. The domain cannot be anything that makes the denominator 0. In this case, it would be either 0 or 5. Both 0 and 5 make the denominator 0, so those are not in the domain, but that's not one of the questions that's being asked here in DeltaMath. Notice that x minus 5's cancel out. And when you do that, you get a much simpler rational function, right? The x minus 5's cancel, and that leaves me -3 times x minus 3 in the numerator and 2x in the denominator. The question is, what happens to that x minus 5? We know that it made the denominator 0, but it becomes what's called a hole in the function. It's also known as a discontinuity. It's discontinuous. Continuous, of course, means it's continuous, but in this case, it's a discontinuity. And when we graph it, it's actually a hole in the function. So what do? Well, we know the x value of the hole is 5, because that's what that factor of x minus 5 turns to. We need to find the y value. To find the y value, we plug into that simplified or reduced equation. So we plug in the 5, and what we end up with is -6 over 10, which of course simplifies to -3 over 5. And that -3 over 5 is the y value of the hole. We now have the xy coordinate. And I would have, if I could design this, I would have put the hole at the top of this list of 5 things because it's the first thing you find. But for whatever reason, it's at the bottom. So I know that that's going to be a 5. And I know that's going to be a -3/5. I'll bother typing these into the equation, into the DeltaMath later, but for now I'll just handwrite them in there. Okay, I'm going to clean up my work here a little bit. I don't need any of that stuff. I think all I really need is the depressed or simplified equation. I can get rid of all that work, all the factoring work. Now that I've taken care of that x minus 5, I don't care about the unsimplified stuff anymore. It didn't erase. Let's try again. Clean up a little bit, clean up the stuff on the top right. I'm going to select this and I'll drag it up so it's out of the way a little bit. Let me just move it right there. Good. Okay. Now, the next thing I'm going to do is I'm going to go through the list of the 4 other things in order. So let's find the horizontal asymptote. I need to know what the degree of the numerator and the degree of the denominator are. But we're going to find the horizontal asymptote. Funny word. Okay, to find this, I'm going to rewrite this by redistributing that -3. And I do that. Remember, there were all these rules about finding the horizontal asymptote, and you have to compare the degree of the numerator and the degree of the denominator. And which one is bigger determines what the horizontal asymptote is, or even if there is one. But in this case, the degree of the numerator and the degree of the denominator are both the same. They're both 1. And so what we're going to do is compare just the x terms, the -3x and the 2x. And so we're going to find the ratio of the leading coefficients is the way to think about it. We're going to find the ratio of the leading coefficients. The leading coefficient, of course, is the number in front of the highest degree term in the numerator and the denominator. In this case, it's the -3 and the 2. That is our horizontal asymptote. And it's an equation of a line. It's a horizontal line, so it's got to be y equals -3 over 2. Notice that y equals is there already. If it weren't, I would have had to type in y equals -3 over 2. That's the hardest thing to find, by the way, the horizontal asymptote. We're not ever going to be asked to find slant asymptotes. They're a little bit harder. And if we have time when we get back, we might spend some time on that. Okay, next up are vertical asymptotes. Vertical asymptotes are anything that make the denominator 0 in the simplified equation. If it made, remember, we canceled out the whole. The whole also made the denominator 0 in the original function, but after we simplify it, after we get that negative 3x plus 9 over 2x, what we want to do is we want to set the denominator equal to 0 and x equals 0. So our vertical asymptote is z equals 0. And I'm sorry, not z equals, x equals 0. And x equals 0 is the y-axis. Okay, let's go on to the next thing. Let me clean up, and let's go look at the x-intercept. As always, no matter what type of function we've done, to find an x-intercept, we set x equal to 0 and find out, no. That's the y-intercept. What makes the numerator equal to 0 is what we want to do. What makes the numerator equal to 0? Because that would be 0 divided by a number. And that's what we're looking for. Because for an x-intercept, we want y to be equal to 0. So I'm going to set the negative 3x plus 9 equal to 0, negative 3x equals negative 9, x equals 3. The x-intercept right there is 3, 0. Notice it's in parentheses. It's got the x and the y coordinate. That's the best way to do it. The y-intercept is the one I started to talk about mistakenly. For y-intercept, we set x equal to 0. As always, we've done this technique forever, right? We've done it with polynomials and logarithms and exponential functions and I don't even know what else, but now we're doing it with rational functions. We're going to set x equal to 0. And you could do that in either of those functions, either the purple one or the blue one that I have at the top, either the factored or the unfactored version. Don't go back to the original one, though. Use one of the simplified or reduced equations. I think it's easier to plug it into the one I have in blue. But anyways, you get 9 divided by 0. 9 divided by 0 is a problem, right? We can't divide by 0. We already knew that dividing by 0 was a problem. That was actually the same as our vertical asymptote. Excuse me, if you look at that. So we can't divide by 0. It gives us a mistake. So what are we going to do? We're going to click that button that says no y-intercept. There is no y-intercept. Why? Because it's a vertical asymptote. It can't be both. It can't have a y-intercept if the y-intercept is the asymptote. Anyways, let's go over here to DeltaMath. I'm going to take those numbers that I had, and I'm going to type them in. Let's see if we get it right. Negative 3 over 2 was the horizontal asymptote. I should say y equals negative 3 over 2, because it is the equation of a line. And then we have x equals 0. And for the x-intercept, we had 3, 0. There was no y-intercept. And the whole, remember, was the very first thing we calculated. And that was at 3, negative 3/5. And I will then go ahead and click the submit button. And I will scan my answers to make sure I don't have any typos there. Yep, they're all good. Yeah, it's a green check mark. I love it. That's a lot of work in each of these. And I really hope you do okay with it. And soon we'll learn how to graph these. But for now, we need to practice finding the 5 characteristics. Thanks very much.